In this video, we will understand how we can perform plane truss analysis using method of sections. The question is, we need to calculate the forces in the members DF, CF and CE for this given plane truss. The first thing that we'll do is, we'll find the reactions, which is VA and VB. Here in the question, angle theta is given to us, which is 45 degree. HA will also come because 20 kilonewton horizontal forces is also acting on this truss. So we'll have VA, HA and VB. Firstly, we'll take moment at A. Taking moment at A, that is anti-clockwise moments is equal to clockwise moments. Now VB is anti-clockwise moment. This is the perpendicular distance. 2.5 plus 2.5 plus 2.5, which is VB into 7.5. Then 30 into 2.5. 30 will produce clockwise moment and perpendicular distance is 2.5, but 20 is producing anti-clockwise moment. So first of all, we'll write that 20 into the perpendicular distance will be 2.5. So VB into 7.5 plus 20 into 2.5 is equal to 30 into 2.5. On solving this, we get VB is equal to 3.33 kilonewton. Then VA will be equal to the total load, that is total vertical load, minus VB. 30 minus 3.33, which is 26.67. Then HA will be equal to 20 kilonewton because here HA is acting in right hand side direction and 20 kilonewton is in its opposite direction. So we can write HA minus 20 is equal to 0, which is HA is equal to 20 kilonewton. And you'll also show the arrows like this. अभी जैसे कि DF member के लिए आई एम अज्यूमिंग इट इज़ सब्जेक्टेड टू कंप्रेशन. सो एरोज मेरे ऐसे आएंगे. Then we have to find for CF member. For CF, I'm assuming compression force. This will be my arrow directions. और CE के लिए I'm assuming tension force. Now, in order to perform the truss analysis using method of sections, we'll have to cut a section like this. This is my section 1-1. अभी जैसे कि मैंने यहाँ पे सेक्शन कट कर लिया है, तो मैं राइट हैंड साइड इक्विलिब्रियम में कंसिडर करूँगी. तो मैं सेक्शन की राइट हैंड साइड ही कंसिडर करूँगी सिर्फ. और अगर मैं लेफ़्ट हैंड साइड को इक्विलिब्रियम में ले रही हूँ तो मतलब मैं सिर्फ लेफ़्ट हैंड साइड कंसिडर करूँगी. जैसे कि आई एम ड्राइंग दिस अगेन. आई एम कंसिडरिंग राइट हैंड साइड इन इक्विलिब्रियम. तो एफ पे जो फोर्सेस लग रहे हैं, आई एम जस्ट शोइंग दैट. एफ डी एफ हो गया मेरा, एफ सी एफ, और यहाँ पे हो जाएगा एफ सी ई. देन बी पे लग रहा है वी बी. देन आई विल कंसिडर मोमेंट एट एफ. आई विल टेक एंटी क्लॉकवाइज मोमेंट्स इज इक्वल टू क्लॉकवाइज मोमेंट्स. यहाँ पे सबसे पहले एफ डी एफ की वजह से मोमेंट लगेगी या नहीं ये देख लेते हैं. तो एफ डी एफ पॉइंट एफ में से पास हो रहा है, इट विल नॉट प्रोड्यूस एनी मोमेंट. एफ सी एफ भी एफ में से पास हो रहा है, सो इट ऑल्सो वॉन्ट प्रोड्यूस एनी मोमेंट. अभी एफ सी ई विल प्रोड्यूस अ मोमेंट एंड वी बी विल प्रोड्यूस अ मोमेंट. तो एफ सी ई की वजह से जो मोमेंट लगेगी पॉइंट एफ पे, दैट विल बी माई क्लॉकवाइज मोमेंट. और वी बी की वजह से जो मोमेंट लगेगी वो हो जाएगी मेरी एंटी क्लॉकवाइज मोमेंट. So here this will be VB into perpendicular distance, which is 2.5, and FCE into perpendicular distance, which is also 2.5. यहाँ से मोमेंट लगी, ये हो गया मेरा परपेंडिकुलर डिस्टेंस, और VB इंटू ये हो गया मेरा परपेंडिकुलर डिस्टेंस. So FCE into 2.5 is equal to VB into 2.5. That is, I'll get FCE is equal to VB, and VB we have got it as 3.33 kilonewton. अभी क्योंकि ये पॉजिटिव आया है, इसका मतलब मेरा assumed direction arrow का सही है, and it is tensile force. Now we'll take left hand side in equilibrium. So here again I'll draw this, and let's consider all the forces that are acting. Here the force which is acting is FDF, then this one is FCF, and here we have FCE, and also VA is acting. We have taken left hand side in equilibrium, so I have drawn the left hand side of my section. Now we'll be taking moment at C. At C only FDF will produce moment, and FCF will produce anticlockwise moment, VA will produce clockwise moment. So VA into 2.5, and perpendicular distance for FDF is also 2.5. For the first one, we had taken RHS is in equilibrium, and for the second one, we have taken that our left hand side is in equilibrium. That's why I've just drawn the left hand side of my section. And now taking moment at C, as FCF and FCE are passing through the joint C, both of the forces won't produce any moment. Only FDF will produce moment at about C. So we have VA into 2.5 is equal to FDF into 2.5. VA is equal to FDF. That is, my FDF is equal to 26.67 kilonewton. And the assumed direction for DF member is compression. So the assumed direction of the arrow is correct. That is FDF. We have compression. Now we'll again consider right hand side in equilibrium, but this time we'll take moment at E. Now for E, FCE won't produce any moment. Here this angle is theta, and theta is given as 45 degree. FCF will have to resolve it in two components. So it will be FCF cos 45, and this will be FCF sin 45. Also FDF will produce moment, and VB will also produce moment about E. Let's just see all of the moments, that is the directions. This FCF sin theta won't produce any moment because it is passing through joint E. FCF cos theta will be producing clockwise moment. Also FDF will produce clockwise moment. VB will produce anticlockwise moment. So we have right hand side in equilibrium, and we are taking moment at E. Clockwise moment is FCF cos theta into perpendicular distance, which is 2.5, plus FDF into perpendicular distance, which is 2.5. Then we have here at F 20 kilonewton force is acting, that also we'll have to consider, and the moment produced because of this will be anti-clockwise. So clockwise moments is equal to anti-clockwise moment. 20 into 2.5 plus VB will also produce anti-clockwise moment. VB into 2.5. VB is 3.33. Now we'll just solve this. We have already found FDF, which is 26.67. From everywhere 2.5 we can take it as common and it will get cancelled. FCF cos 45 plus 26.67 is equal to 20 plus 3.33. And on solving this, we get FCF is equal to minus 4.72 kilonewton. As we have got negative sign, that means the assumed direction is wrong. For CF member, we have assumed it as compression, but we have got negative sign. It means that in CF member, the force will be tension. So here I'll just write that FCF will even correct the arrow direction. FCF is equal to 4.72 kilonewton and it is tension. So here at the end, when you'll draw the diagram again for CF member, you'll draw the arrows in this way because CF is subjected to tension. Also, you'll highlight the forces. FCE is 3.33 kilonewton, FDF 26.67 kilonewton, and FCF is 4.72 kilonewton. This is how you can perform the plane truss analysis using the method of sections. Thank you.